Hello and welcome to this video on Cubit scripting. This is the graphical user interface of Cubit, which you are probably already familiar with. You can use it to create meshes for your simulations. However, working with the GUI is not very scalable for larger projects. There is an alternative way to create your meshes with Cubit, which is using Cubit's own scripting language. This is far more scalable than using the GUI, and in my personal opinion, even for smaller projects, it is more convenient. In this video, I will go through a small example to show you the most important features of Cubit scripting. For a more elaborate example, look at the meshing example in the OpenCFS user documentation. I use the virtual machine that is provided in this course, but all that I show here also works on any other machine that supports Cubit. To write my Cubit script, I will use the built-in editor in the Cubit GUI. However, you can use any text editor to edit your Cubit scripts. You can open the editor here. Cubit scripts are called journal files and have the ending .jou. You can find the example discussed in this video in the OpenCFS user documentation. My example is a 2D square domain with a hole in it, like is shown in this image. I will create the corresponding Cubit script step by step and show you the necessary commands. At the beginning of every Cubit script, there should be the reset command. This removes any old entities or meshes that might be there. In the second step, I set the parameters of my mesh as variables. The way to declare and assign variables in Cubit is by using this hashtag and curly bracket syntax. Here I have set the radius to 5 times 10 to the minus 4, the side length of the rectangle to 5 times 10 to the minus 3, and the element size to 0.1 times 10 to the minus 3. For creating the entities of your geometry, there is the create command. First I create the square domain using create surface rectangle with width L and height L in the C-plane. You can see here that to use variables in a Cubit script, you need to use this curly bracket syntax. If you don't use the curly brackets, Cubit will not use the assigned value of your variable. I think the commands width and height are self-explanatory. C-plane means that my surface is normal to the Z-axis. You can execute the Cubit script by using the play button here in the editor. Now you can see that the rectangle was created. You can also type commands directly in the graphical user interface. For example, if you copy the text in my journal file and paste it in the command panel, you can see the effect is the same as when I run the script. Let's say that I want to move the rectangle so that the lower left corner is at the coordinate origin. For this, I first need to select the surface I want to move. Selection of entities is a big part of Cubit scripting. The first method of selection is via the entity index. For example, here I could use the command move surface 1 in x direction by L half. This will move the surface L half in x direction, and here I know that the index of my surface has to be 1 since there is only one surface. For more complicated cases, selection via index is not the best approach. I will show you a better method for selection in the next step. Now I also move the surface L half in y direction, and now I will make the hole. To make a hole in the domain, I will first create a circle with create surface circle radius r C-plane. Now I move the circle to where the hole should be. Let's say it should be at coordinates L half in x direction and L3 in y direction. Now I will select the circle with a more scalable method, that is, via its coordinates. If I execute the script, you can see that the circle is at the origin right now, so its center has coordinates 0, 0 in x and y direction. I can use this to select it by using move surface with x coordinate is 0 in x direction by L half. If I execute this, we can see that the circle has moved and that the coordinates of its center have changed. Its y coordinate is still 0, so to move it in y direction, I can use move surface with y coordinate is 0 in y direction by L3. You can also move in multiple directions with only one move command. So in this example, you could also just use the move command, select the surface, and then type x L half and y L thirds, so you could put all of that in one command. Selecting by coordinates is probably the most scalable approach. One other way would be to assign names to your entities. For example, the command surface with y coordinate is L half, name plate, will assign the name plate to the rectangle, and the next line will assign the name plate hole to the circle. This might be convenient in some cases, but in general, selection via coordinates is what we would recommend. As a little side note, we also recommend using a less than or greater than instead of the equal, because in some cases, due to floating point arithmetic, Cubit will not find an entity even though you have rightly specified the coordinates. To cut the hole in the rectangle, we can use the Boolean operation subtract. Here I will use the names I gave to the entities to show you how to use entity names. So I use subtract plate hole from plate, and when I execute this script now, you see that the hole was cut in the rectangle. So our geometry is already finished. Before I create the mesh, I specify blocks and nodesets, which can later be used in the simulation. With the command block1 add plate, I create a block and I name it as plate. This can later be used to specify the domain in which the PDE should be solved. Now I create a nodeset with nodeset1 add curve with y coordinate is 0, which is the lower side of the rectangle. I name it L excitation, which I can later use to add my boundary conditions in my simulation. Now we come to the meshing. For more complicated geometries with multiple entities, you will need the commands imprint and merge here. In these cases, Cubit often can't mesh the geometry on the first try, and you have to change parameters until the meshing works. This can be tricky at times, so don't be surprised if the meshing does not work immediately. It sometimes takes some trial and error. I define the mesh size in the plate with plate size HL. And now I mesh with mesh surface all. When I now execute the script, you can see that Cubit has successfully meshed the domain. You can also save the mesh from the Cubit script by using export ansys cdb, so this will export the cdb file, and then specify the file name. You can also use your variables in the file names like here. I have defined the variable setup number in advance. I will show you in a second what it means. The Cubit scripting language also allows you to use loops and branches in your script. To show you how to use this feature, I will now change the script so that it loops over 3 different setups of my mesh. First, I set the setup number to 0, and then I use the command loop 3, and you see again we have this hashtag in curly brackets syntax. I also put end loop at the end of the script. This will execute the lines within 3 times. Now I want the setup number to increase by 1 in every iteration, so I use setup number is setup number plus 1. Let's say that in the second setup I want the radius of the hole to be a little smaller. I can achieve this by using if def setup number is 2, set r to 4 times 10 to the minus 4, and put an end if here. This is how you use branches in Cubit scripts. So in the iteration where the setup number is 2, the radius of the hole will be changed to 4 times 10 to the 4. And let's say for the setup number 3, I want the radius to be 2 times 10 to the minus 4. I can do it like this. So I have now made a loop around the script, which changes the size of the hole in each iteration. Let's run it and see what happens. As you can see, Cubit has created 3 different meshes. In the end of the script, I've already included the setup number in the file name in the export command. This way I get 3 CDB files in my Cubit directory with the 3 different meshes. This is it for the Cubit example. To conclude it, I want to give you a little warning. Debugging of Cubit scripts can be tricky, because Cubit does not stop at a command that it cannot execute. If a command raises an error, you can see that here in the error panel. Sometimes commands only give warnings, which you have to look for here in the command panel. If you change something in the middle of the Cubit script, it is easy to create an error or a warning that you don't immediately see when running the script, so be mindful of that. To end this video, I want to give you some tips and tricks for automating. First of all, you can run Cubit scripts from the terminal. To do that, you just have to find your journal file and then run Cubit and then the name of your file. In my example, my file is called plate.ju, so I run Cubit batch no graphics, no journal, plate.ju, which again creates the 3 CDB files. Cubit scripts are also compatible with Python. The Cubit editor has the feature to translate to Python here. You can see that the code changes in a way that the Cubit commands are handed to a Cubit API. You can use this to use some Python functionality you might need or prefer. For example, you could change this Cubit loop here to a Python loop. Generally, for most tasks, the Cubit scripting language will suffice, but for some special cases, you might find the Python compatibility convenient. The Cubit GUI also has a Python panel here, so again, if I copy-paste the Python code in this panel, you can see the Cubit creates the meshes as before. That's it for this video. I hope you found it helpful. Thanks for watching and bye.